we can express the products or the multiplication of two trig functions, sines and cosines, as sum or difference problems using these expressions right here. So it's really simply a matter of taking the expression you're given and matching it up to the appropriate formula. So here I'm given the product of two trig functions, the product specifically of two sines. I've got sine times sine. And so looking at those formulas from the other screen, I can see that that's really going to match up to this top formula right here, sine of A times sine of B. So let's go ahead and take that formula and apply it to write this problem as the sum or difference of two sines. So A and B are just your two different angles you're given. So applying that formula, I get 1/2 times the cosine of A minus B. So I'll go ahead and just do that subtraction in my head. A minus B would leave me with 2 theta. 6 theta minus 4 theta is 2 theta. And then minus the cosine of A minus B, so 6 theta minus 4 theta. Oops, I'm sorry, times the cosine of A plus B, so 6 theta plus 4 theta gets me cosine of 10 theta right here. And notice I've used parentheses around my different angles in there, and then believe it or not, that's your answer. That's my product written as a difference problem, okay? So these problems are that easy, it's just a matter of applying the appropriate formula. So next up I've got a cosine times a cosine. So looking back at the different formulas, I can see that cosine times cosine is going to be this second formula right here. So let's go ahead and apply that and see what we come up with. So I'd start with 1/2 times the cosine. Again, it's these are they're very similar looking formulas, so just make sure you're looking at the right formula. It was the cosine of A minus B, so 3 theta minus 1 theta is 2 theta. And then plus the cosine of A plus B, so 4 theta. And again, that's my answer. Now the only thing that could really add an extra step to this is if you had a negative angle in here. And so for our last example, we'll take a look at what to do with that. It's really not that much more difficult. Once again, I've got a sine times a sine, so I can use the same formula we used in the first example here. So again, that's A and that's B. And it does matter what order those are in, so just make sure that those are in that order. So I'd have 1/2 times the cosine of A minus B, and this time I get negative 4 theta, and so that's the negative we'll talk about in a second. And then finishing my formula, I have minus the cosine of A plus B, so again that's going to be 10 theta. Okay, now that would be my answer. However, I never want to leave a negative angle in these problems, and so using our even-odd properties that we've discussed throughout this semester, I can always get rid of a negative angle in there. If you're working with a cosine, that negative sign just vanishes. We can ignore it completely. The cosine of negative 4 theta is the same as the cosine of positive 4 theta. So I'll just make that a plus sign or just erase it completely. And that's true if you're dealing with a cosine. Okay, so that is going to be my final answer. But let's suppose, just to talk about it, let's suppose that this was actually a sine. It's not. But let's suppose it was the sine of a negative angle. Again, I can get rid of that plus sign or that negative sign, but my negative sign has to come out in front of that whole term right there. So cosines, ignore your negatives. Sines, make sure that negative comes out in front, and you'll have your answer written as a sum or difference.